Hi, good evening. This is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering. Today we are going to say about the floating and fixed point processors, the difference between. First, before going to the subject, first we will say about the floating and fixed number. Floating point DSP processors use floating point arithmetic where numbers are represented as a sign bit, exponent and mantissa. This allows for a wide dynamic range and variable precision. For example, IEEE 754, the dynamic range is approximately 1.175 into 10 to the power 381.175 into 10 to the power minus 38 to 3.402 for normalized numbers, and the precision varies depending on the number's magnitude. So for fixed point DSP processors on the other hand use fixed arithmetic where numbers are represented within a fixed number of integer and fractional bits. This provides a fixed dynamic range and precision minus 128 plus 127.99. Let us move on to the difference between the floating and arithmetic processors. Floating point and fixed point processor are distinct types of hardware designed to handle numeric computations, each with its own characteristics and applications. First, we will see the dynamic range and precision. Floating point arithmetic often a wider dynamic range and higher precision compared to fixed point arithmetic. So this makes floating point processors suitable for applications requiring high accuracy and the ability to handle signals with large variations in magnitude. In the fixed point arithmetic has a limited dynamic range and precision determined by the number of bits allocated for integer and fractional parts. While fixed point processors may not offer the same precision as floating point processor, they can be more efficient for certain applications with modest precision requirements. Next one is a fixed point processor in arithmetic precision, dynamic range and resource utilization and application. So in this way we are going to differentiate how the fixed point and floating point processor varies. So fixed point processors arithmetic precision is fixed point DSP processor use fixed point arithmetic which provides a fixed dynamic range and precision. And resource utilization, fixed point arithmetic is a more resource efficient in terms of hardware resources since it involves simpler arithmetic operations, can be implemented using basic integer arithmetic units. So in the point of application, these processors are commonly used in applications where computational efficiency and cost effectiveness are prioritized over precision, such as telecommunication control systems and embedded signal processing in consumer electronics. In the floating point processor, the arithmetic precision which allows for a wide dynamic range and variable precision. This means they can handle signals with large variations in magnitude and provide high precision. The next one, dynamic range. As per the dynamic range is concerned, floating point DSP processors have a wide dynamic range compared to fixed point processor. This is beneficial for applications where a broad range of signal magnitude needs to be accurately represented. And coming to the resource utilization, this processors typically requires more computational resources. For example, silicon area, power consumption. So compared to fixed point arithmetic due to the complexity of floating point operations. The applications of floating point DSPs are suitable for applications requiring high precision and wide dynamic range such as audio and video processing, scientific computing and simulations. These are the applications floating point DSP processors are used. Next we will see the table of different characteristics for floating and dynamic. So the floating point processors are 32-bit and fixed point 16-bit. So dynamic range much larger and in fixed it is smaller. Resolution is comparable in both processors. and programming, ease of program is comparable to both the processors. Compiler efficiency is much easier in floating point, but it is difficult in fixed point. Power consumption is more efficient in floating point and less efficient in fixed point. Chip cost and system cost is comparable, and design cost is less in floating and it is more in fixed point. Time to market is faster in floating point and slower in arithmetic. So hope this video you can understand the what are the different types of numbering system and different types of DSP processors, the basic difference between these two. Thank you.